Study, dark matter doesn't exist, the universe is 27 billion years old, Earth.com. The universe feels simple at first glance: stars, gas, dust, and the gravity that binds it all. Then you look more closely and realize that nothing could be farther from the truth. For decades, the standard picture has said that most of what is out there is not what we can see. It is a mix of ordinary matter and two invisible components often called dark matter and dark energy. That picture has guided textbooks, space missions, and how we read the sky. It has also raised tough questions that have never quite gone away, mainly because of the fact that dark matter and dark energy have never actually been seen. Challenging dark matter's existence. A new line of thinking takes those questions seriously and suggests we may not need those dark, invisible components after all. After years spent probing long-standing cosmology puzzles, physics professor Rajendra Gupta has proposed a model that aims to explain the universe without dark matter or dark energy. Gupta teaches astrophysics at the University of Ottawa and argues that familiar assumptions might be impeding progress. The study's findings confirm that our previous work, JWST Early Universe Observations and Lambda CDM Cosmology, about the age of the universe being 26.7 billion years has allowed us to discover that the universe does not require dark matter to exist, explains Gupta. Tired light and the CCC theory. Gupta's approach blends two concepts: covariant coupling constants CCC and tired light TL. CCC asks whether the so-called constants of nature, like the strength of forces or the speed of light, might shift across time or space. If they do, even slightly, many calculations about how the universe evolves would change. TL offers a different take on why light from faraway galaxies appears redshifted. Instead of treating redshift solely as a sign of cosmic expansion stretching light, TL suggests that photons shed energy over vast distances, shifting their color toward red. Taken together, the CCC plus TL model seeks to account for cosmic signals. Most scientists think dark matter is real. The idea of dark matter did not arise in a vacuum. In the 1930s, astronomer Fritz Zwicky noticed that galaxy clusters seemed to move in ways that did not match their visible mass. Later, astronomers saw that many galaxies rotate faster than expected at their outskirts. Something appears to add extra gravity. Gravitational lensing, the way mass bends light, also points to more pull than starlight alone can explain. In the standard breakdown, dark matter is thought to make up about 27% of the universe. Ordinary matter, everything we can directly detect, adds up to less than 5%. The rest is labeled dark energy, a placeholder for whatever drives the universe's accelerated expansion. This picture also includes a commonly accepted age of roughly 13.8 billion years. Questioning the need for dark matter. Gupta contends that if the forces of nature weaken over time, we do not need dark energy to explain why the expansion appears to speed up. He also argues that major observations can be matched without dark matter by allowing constants to vary and by letting light lose a small amount of energy as it travels long distances to reach us, the observers. Contrary to standard cosmological theories where the accelerated expansion of the universe is attributed to dark energy, our findings indicate that this expansion is due to the weakening forces of nature, not dark energy, Gupta continues. Redshifts and cosmic observations. A substantial part of the work centers on redshifts, how light shifts toward longer wavelengths as it travels. The analysis compares how galaxies are distributed at low redshift with patterns from the early universe at high redshift. The claim is that these signals align under the CCC plus TL approach without requiring dark matter in the equations. There are several papers that question the existence of dark matter, but mine is the first one, to my knowledge, that eliminates its cosmological existence while being consistent with key cosmological observations that we have had time to confirm, Gupta confidently concludes. What does all of this mean? If CCC plus TL continues to pass tests, much would change. The model would offer new routes to explain the cosmic microwave background, the timeline of how galaxies formed and grew, and the way light bends on its journey to our telescopes. It would also change how we read distance and time from the sky, since redshift would no longer be only a ruler for expansion. It would challenge the Big Bang-anchored timeline. Those are substantial claims that require careful tests. Testing Gupta's theory. Specific predictions need to be articulated. Any model has to meet observations head-on: galaxy rotation profiles, lensing maps, the pattern of hot and cold spots in the microwave background, and the way galaxies cluster across hundreds of millions of light-years. If constants vary, even a little, that could leave signatures in atomic spectra from distant quasars. If light tires, the effect should be measurable with enough precision and a clean way to separate it from other causes. Teams are already poring over deep sky surveys, precise supernova samples, and high-resolution microwave maps. As instruments improve, the bar for any alternative rises. The goal is straightforward: make a clear, testable forecast, then see if the universe agrees. Dark matter, CCC plus TL, and next steps. Two central questions remain. Are dark energy and dark matter just bookkeeping devices we used while working with fixed constants and a single redshift story? Could the true age of the universe be significantly older than the standard estimate? The only way to answer is to press for independent tests that can separate one picture from the other. Researchers are tuning methods to compare models fairly, using the same data pipelines and error checks. That helps avoid apples to oranges results. If CCC plus TL keeps matching the sky, interest will grow. If it stumbles on a key observation, that will be clear too. Cosmology moves forward when claims meet data. This study advances a bold alternative, a universe where constants can change, light can lose energy across great distances, and neither dark matter nor dark energy need to be included in the ledger. It offers clear, testable statements about cosmic age and the cause of the apparent acceleration. The work will be validated or refuted by measurements. That is how the field operates, no shortcuts, no hand-waving, only observations and models that either fit or fail. The full study was published in the Astrophysical Journal. Like what you read. Subscribe to our newsletter for engaging articles, exclusive content, and the latest updates. Check us out on EarthSnap, a free app brought to you by Eric Rowles and Earth.com.